What do you mean by statistics? It's a process involving collection of data, yes, classification of data, representation, which includes tabulation. Actually, if you go word form, descriptive form, then tabulation, then diagrams or graphs. Then next step is analyzing, and the next step is interpretation. Okay, just let it be this. Now come for an example where I conducted a test for 10 marks and I collected the students' marks. Already I have done this earlier, but I just want to link that concept. So this is for 50 students, for example, for 50 students. I'm not going to list out for all 50 students, just for 50 students. Let me take for some 20 students, okay? 20 students. So how the marks would be listed? 3, for example, 3, 6, the second student's mark. I'm asking first student's mark. She will say 0 only. So let me have 0 itself. Okay, don't mistake. She says 3, she says 6, he says 5, 4, another one says 9, 10, another one says, it's for 10 marks, right? So another one says again 0, 4, 7, 8, again 10, 9, 2, 1. So how many students? 15 students gone. I need to have 20 students marks. So like 4, 3, 2, 5, 6. So what I have done here? I have collected the data. Am I right? What's the first step? Collection of data. I have collected the data. Then I need to classify. So how am I going to classify? Marks I would classify as what? How? Please tell me. 0 is the first mark and what's the last mark? 10. Usually how we do is we'll find the range. What's the range? We know the formula for it. What's the range? Highest minus the smallest. Okay. Least. Which means 10 minus 0, which is 10, happens to be a small range. So how can I classify here is from 0, 1, 2, 3 up to 10. That is independently. If I classify this way, this is what you call as, yes, this is what you call as discrete series. In case, if I have this range happening to be 100 marks, which means the highest mark is 100, least mark is 0, which means instead of 10 marks, I am having this as 100 marks. What will happen? My range will be bigger, right? So in that case, how can I classify? Yes, please. How can I classify in that case? How can I classify? I can have 0 to 10, 10 to 20, am I right? Or either this way, like 80 to 90, 90 to 100. Or I can have it as, yes, please, I can have it as 0 to 20, 20 to 40, anyway, your wish, up to 80 to 100. This is in terms of tens, this is in terms of 20s, 20, 20, 20, okay? If I classify in this way, I call this as continuous series. Actually, we have 3 types of data, right? 3 types of series we have. What are the 3 types? First is this individual observation. Second is discrete. Third is continuous. Please try to understand the difference between individual and discrete. Tell me whether this is individual observation or discrete. Actually, I'm used here as discrete. And just say this is discrete itself. This is individual or discrete one. Okay. Tell me why I cannot use this as, or why I don't want to use this as individual. If it is individual, it should be very easy. Just say, I need to have only few observations. But how many observations I have here? 20 observations. So I need not take it as individual observation. So, see, looking at the value, if I ask you from the 20 values, 20 students mark, if I ask you, who scored the highest mark? You'll say, these 2 students. Who scored above 6? You'll say, 6 and above 6. 6, 7, 8, 9, 9, 6. Okay, fine. Who scored below 5? 5, 4, 4, 2, 1. Yes, it's easy. Because it's only 20, it's easy. What happens? Goes 100 and 100 of students' marks. It will not be easy, right? So what I can do is, I can go for discrete. Okay? Discrete means, instead of having just the observations like this, what I do is I go for classifier, marks and number of students. Okay. In between, I'll have something called as, remember, tally bars or tally marks. Marks, how I'm going to classify? Yes, please join. Starts from 0, least mark, highest mark 10. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. 7, 9 and 10. Tally bars 0. Where it will come? Here. Am I right? Then 3. So let me have an into mark. 3 over here. 6 over here. 5 over here. I'm just plotting all the values like, okay. 4. Yes, please. Over here. 9 over here. 10 here. 0 here. 4 here. 7 over here. 8 below that. 10 another line. 9 another line. 2 1 here 1. 4 I think already have 2. Yeah. Then 3. Then 2. Then 5 and 6. Then I have the number of students. How many? 1 and 2. See, I count here number of lines 1 and 2. So I write it as 2. Next is 1, 2, 2, 3, 2, 2, 1, 1, 2, 2. So totally I have to get 20 students. This is how I do when it is a discrete series. If it is individual observation, what I do? I'll not do all these things. See, actually by definition, statistics is first step you have to go for collection of data. Yes, individual observation also we do it. Second is you have to classify the data, where in the case of individual observation, you will not classify the data because not necessary. Third, you need to go for representation, either descriptive or tabular or diagrammatic or graph. Will not do that. Okay, classification also will not do it. Analyzing, yes, we'll find mean, median, mode and all. This is in the case of individual observation. But in the case of discrete and continuous, where the range is very high, I have to go for finding, collecting the data, classifying, representing, yes, into, okay, then analyzing and interpretation. For all these cases, it happens. Okay. Now, please join. Not at over. Now tell me, how I find mean value? If this is dealt as individual observation case, how do you find mean value? I'm talking about arithmetic mean. Yeah, please. What is arithmetic mean formula? Individual observation. Summation x by n. What do you mean by summation x? You add all the value, which means you take 0 plus 3 plus 6, 5 plus 4, etc. up to the last value divided by 20. Instead, what you do? Sometimes, ma'am, here you have 2 tens, ma'am. So 20, ma'am. How many nines? 2 nines, ma'am. So 18, ma'am. Why you need to add like 10 plus 10 plus 9 plus 9? We directly take as how? 2 into 10, right? How you take this 18? Because you have 2 nines. You take 2 into 9. Then for 8, how many 8s you have? Only 1 8. I can take it as 1 into 8. That's what only we did here. See here. How many 3s? 2 times. How many 4s? 3 times. So instead of doing summation x by n, because I find many numbers are repeated, what I can do here is I can take this marks as x, and this is number of students, frequency. We call this as frequency. No matter how of frequencies, how frequent, how many times it occurs, how many times it happens. That's what I call as frequency. So instead of taking the summation x by n, what I do here is I take summation fx by the total summation f. What is this n? The cardinal number of size of observation. Here is 20. See what is this? This one, summation f, the total, the number of observations. Usually for discrete and continuous series, we will not use small n, instead we use capital. So the formula here is summation fx by summation f or capital. Okay. See, in the case of sample and population, x bar is arithmetic mean, here mu is the arithmetic mean. You remember I was discussing this earlier. Standard deviation, here is small s, here is sigma. Here is small n and here is capital N for size. Usually when we go for discrete, and this is a different concept, you should not mix that and here, this one here. This is a different concept where small n is used for sample size and capital N is used for population size. And in the case of individual observation, discrete and continuous alone we use capital N, and for individual observation we use small. Okay, so seeing this capital N, don't think we are talking about population. There also for finding arithmetic mean, I'll be using x bar only. There also for finding standard deviation, I'll be using S only. I'll not use mu or sigma. Okay, because we are talking about sample. We're not talking about population. Again, இப்போ உங்களுக்கு டவுட் வந்துச்சுன்னா அப்ப பாப்புலேஷன் பத்தி பேசினா என்னது இந்த கொஸ்டின் ரேஸ் ஆச்சுன்னா பாப்புலேஷன் பத்தி பேசினா வில் பி டிஸ்கசிங் திஸ் இன் தியரட்டிக்கல் டிஸ்ட்ரிபியூஷன் binomial Poisson, that's all dealing with population. If I get a set of values, we call that as sample because we cannot deal with population. Population is thousands and thousands of values. How many values we are discussing here? Only few. Few means 1,000, some 10,000, some 1 lakh. That is few only. Seeing the number, don't think it's a very big number. Okay. If I talk about a few, it can be few in terms of numbers, probably natural numbers. If I talk about it, maybe in lakhs also few only. Because what's the end of the natural number? What's the last natural number you know? You cannot say, right? It's an infinite term, like it goes on. So you cannot talk about the last number. So when we talk about counting on natural numbers, you cannot talk about the last number. So if I know a number, we say it's definite. We say it's discrete. Okay. So this is about discrete. Continuous, I'll discuss that later. So let me go for this. Discrete frequency distribution. Yes, please join. Please try to understand the heading here. Marks and what is given power? Marks and number of students. Here the marks starts from 10 only and the highest mark secured by a student is 19 only. That's why we are considering only 10 to 19. How many have secured 9 marks? See, it's not under consideration. So what we consider this as 0. It's an assumption. How many have secured 15 marks? Which mark is secured by many number of students? 13. Why? This is the highest one. Okay. So obviously seeing the values, you can easily guess this is the mode value, right? Which is the mode value? 13 is the mode value. We'll not say 100 is the mode value. Mean, median, mode and all lies in marks only. Number of students is number of counts. Frequency, number of happenings, number of occurrence, number of counts. That's what we call as the number of students. So here also we are going to find all the big list. What are the lists we have? What's the list we have? We are going to find all these things. Yes. We are going to find arithmetic mean, geometric mean, harmonic under mean. Under positional average, we'll be finding median. Under fractiles, quartile 1, quartile 3, octile 6, decile 7 and P75, percentile certificate. Then mode. These are all covered under averages. Then we'll go for dispersion. We'll be completely working with both absolute measure and relative measure. Now let us go for arithmetic mean. Yes, you can please join or you can start working. So you can start. The first formula for arithmetic mean is what? Summation x by, summation fx by summation n. Just have a look on the formula. Wherever I had summation x by n, what's the formula here? Instead of n, I have capital N. Instead of x, I'll be having f into x. Likewise, remember geometric mean formula? Most of the cases we use antilog formula only. Okay. So this is antilog of, this is in the case of individual observation. Antilog of, yes, please join. Antilog of 1 by n summation, 1 by small n summation log x. Wherever you have x, I'll be taking log x. So x is taken f number of times, which means log x is also taken f number of times. So the formula will be summation f into log x divided by n taken antilog. See, please make a note somewhere here. It's very important. It's not summation log f into x. Please remember. It's not summation log f into x. For x, you take log x. Okay, you take logarithm of x. Then for that, you multiply f. Why you multiply f? That many number of times it occurs. Then you will get this as log x into f. Then you add all the values. You will get summation f log x. Then you divide by n. This is the process. This is often repeated question. This is not the format. This is the format. You take x, take log x, then multiply by x. Okay. In this problem, we are just discussing this one, right? If for this problem, if asked to find geometric mean, what do? For 0, you take log 0. Am I right? For 3, you take log 3. For 10, you take log 10. How many 10s are here? 1, 2. That means you take log 10 and you take for 2 times. Am I right? You should not take this as log 2 into 10. It's an abrupt mistake. Don't do it. Okay, don't take it as 2 into 10, then log. No. For 10, you take log 10. Okay, then you multiply by 2. Okay, so this is second formula. Then for harmonic mean, what's the formula? Under individual observation, we have n divided by summation 1 by x. The same concept. For x, you take 1 by x. Then multiply by f. So you get capital N divided by summation f by x. So what you're doing here? For x, you take 1 by x. How many times x appears? F number of times. Which means 1 by x also appears f number of times. 3 means 1 by 3. 10 means 1 by 10. How many times 10 appears? 2 times. Okay, how many times 1 by 10 will appear? Also 2 times. So this becomes f and this becomes 1 by x. So f into 1 by x also can be written as f by x. You agree? Yes, f into 1 by x is f by x. Then you take all the summation values. Just summation. Then you take it as a denominator. So the formula is n divided by summation f by x. Is it okay? Yes, fine. You can start with the problem. First go for finding all the 3 means. Then we'll continue with the next unit. Yes, please. So what you did over here for arithmetic mean, you just directly multiplied f and x, right? So summation fx by n. So you directly multiply f and x, then take the summation. So we have f, we have x, f. Then one column is taken for f into x, where you add all the values. It's 8767 divided by 581. I request you to round off for 2 decimal places. Okay, so 15.09. You got it? Then geometric mean, usually we have 2 formulae. One formula we have taken directly with respect to antilog. What's the original formula by definition? Okay, let us go for individual observations definition. What is the original formula by definition? Nth root of the product of all the values, which means x1 into x2 up to xn. Okay. If I have x1 appearing 2 times, in the geometric mean, I'll be taking this as x1 into x1. Am I right? Which is nothing but x1 square. Am I right? In case this x1 is appearing for f1 number of times, then in geometric mean, I'll be taking this as x1 power f1. Yes? This is okay? Is this point okay? Likewise, if I extend x1 appearing for f1 number of times, x2 appearing for x2 number of times, x3 appearing for f3 number of times, likewise xn appearing for fn number of times, then I'll be taking this as x1 power f1. This one as x2 power f2. Why power? Because into. If I take 2 into 2 into 2 into 2, which means 4 times. I'll not write this as 4 into 2 because it's not addition, it's multiplication. So I take this as 2 power 4. So here it will be appearing as x3 power f3. Here it will be appearing as xn power fn. So now I take this as, yes, capital nth root of, so capital nth root of x1 power f1 into x2 power f2 all multiplied till xn power fn. Is it okay? Now I have to go for taking logarithmic values. Shall I take? Yes. I have 2 laws. One law is log of m power n will be taken as n log n. Is it right? Log of m plus n, m into n. M into n will be taken as log m plus log n. Now let me apply this over here. Yes, tell me. What happens? Next step. Geometric mean, if taken log geometric mean will be nth root I have, which means the whole thing multiplied by, taken power of 1 by capital N. So this happens 1 by capital N log of, okay, everything taken inside the bracket x1 power f1 into x2 power f2, so on up to xn power fn. First step. Next step, 1 by n as it is. This is in the form like log m into n into x, so on. So instead, if I have multiply, what I can do? I can take log m plus log n. So I can take this one as log x1 power f1 plus log x2 power f2. So on up to log xn power fn. Log xn power f. Is it okay? So next step, 1 by n. Okay. Now apply this one. This one, m power n, which means n log n. So this is f1 log x1 plus f2 log x2, right? So on fn log xn. So this is 1 by n f1. See, I have f1 log x1, f2 log x2. So if I take addition of all the values, I'll get summation f log x. Okay, instead what we do is, actually we have to take fi log xi, I is equal to 1 to n. Okay, 1 to capital N. Okay, so right. So shall I write this as summation f log x divided by n? This is what? This is nothing but logarithmic of geometric mean. Do you agree? Now see this formula alone. It's not yet over. See this formula alone. This looks somewhat similar to summation fx by n. Am I right? Instead of x, what we are taking? Log x. But this will not give you the geometric mean value. Instead, this will give you the logarithmic of geometric value. So what you have to do? You have to reverse it by taking, see, reversing means anti, A-N-T-I, anti, which means anti-log. That's why we have this as anti-log of 1 by n summation f log x. And the other side, I have anti-log of log of geometric mean, which means this and this will get reversed, inverse functions like reverse. So this will happen to be a 1 back. So this will be geometric. So what's it mean? What's the formula for geometric mean in terms of log and anti-log? Geometric mean is anti-log of 1 by n summation f log x. Anti-log of 1 by n summation f log x. Is it okay? Okay. So sometimes you may expect, in case your question paper happens to be a very tough one, you may expect this one. Given this value, you may be asked to find the geometric mean. This is how you find the geometric mean. Given this value, you take anti-log for this value, and the anti-log value will be given in the question itself. But instead, they will not give one value; they'll give 2 or 3 values. Like we were discussing earlier for this problem, 1.1746. We get it as 1495. I remember. Instead of 1, they are giving it as 1. They'll get as 0.1746 is 1.495. Okay, they'll ask you the value now. But what actually value I'm getting here? 1.1746. But in the question it's given as 0.1746 is 1.495. What I have to write here now? My answer will be 14.95. They will give this value in the question paper. They will not give the log table or anti-log table. You have to find anti-log for this value, which means you take the help of this value 1495 without decimals, and you place a decimal in the after the second place. Okay, so this is about geometric mean. Actually, you need not have writing on all these. You can find in single material. Can you turn to the last but before page? Almost end of the page, I think. Over here. See in page number 2.27. Can you find a complete table? There's a working given for all the 3 cases. Geometric mean formula working for given for individual observation, discrete and continuous. You can just have a look. Okay, the derivation is not necessary, but this will be helpful for locating the formula. So you can understand, right? It's 1 by n. Actually, you have to have anti-log. Please correct it. This is 1 by n, anti-log of 1 by n. Okay. Yes, please. In the case of continuous, instead of using x, I'll be using m. See, in the case of discrete, we use x, right? See, in the formula, everywhere we'll get x. Instead, we'll use m here, which is mid-value. Yes, please make a note. What is the value you got for arithmetic mean? Am I right? Geometric mean 14.95. Harmonic mean 14 point. Actually 802. So I can have it as 80 itself. No issues. We have relationship between all the three means, right? What's the relationship? Either greater than or equal to. Remember? And now, see, when you have equal to, it's not always greater than or equal to. It's greater than or equal to. Okay. When we have equal to, and all the values are same, we'll have equal to, right? Now tell me, here in our problem, the type 2 problem, we have all different values. How you say all different values we have? How you say I'm having all different values? What value I have here? 10, 11, 12. Different values only, no? Only 8 values are the same, having the same 10 number. Remaining numbers, totally it's 581, I think. Yeah, 581. Out of 581, there may be repetitions, but even one single value happens to be a different value, then I cannot say it's all equal. All the three means are equal. So here, I'll get as strictly greater than greater than. This is often repeated question. Please place some important mark over there. Important in the sense of concept wise important. Okay. So probably how your question may be asked is an arithmetic mean value for a set of data is given to be 15.09. Geometric mean for a set of for the same set of data is given to be 14.95. What is the harmonic mean? Okay, option A, B, C, D will be given. One value may be 14.99. Okay, one value may be 14.90. One value may be 14.98. One value may be 15.10. Which one you would answer? See, this value happens to be lying between here. Actually, have the relationship arithmetic mean greater than geometric mean greater than harmonic mean. Okay. So, I need to have the harmonic mean lying less than these two values. So, this is not the value. So, I may have this as the value, right? Yeah. What about this one? No, I cannot have it. This one I cannot have it. Okay. மேம் நீங்க 14.0 இருக்கு நீங்க 14.90 போட்டிருக்கீங்களா யாருக்கு தெரியும் அது 14.8 நமக்கு தெரிஞ்சனாலும் தெரியும் தெரியாதுன்னா தெரியாது தானே okay so it's 14.90 is the answer. So this type of question you can expect. So mean over bar. Shall I go for median? Yes. What's the median formula? What you have to do? It's a two-step way of finding. What you have to do in the first step? First step, what you have to do? You have to arrange in order. Either ascending order or descending order. Usually we'll do in ascending order. First arrange in ascending order. Next, what is that we'll do? What is median? Is the size of n plus 1 by 2th observation. You remember? Only difference here from the individual observation is instead of small n, we use capital. Okay. And there is one more difference also. Let me discuss that later. Let me go for the problem directly. I'll work out this problem. Yes, can you get me the values for marks and number of students? Number of students is nothing but frequency, right? Yes, tell me. Starting from 11, 12, 13, starting from 10 now. Okay. Starting from 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, 19. Number of students? 75, huh? 50, 30. Right? Yeah. Now let me go for the formula. Size of n plus 1 by 2th observation. What is n? What is n? The total is the n, which is summation n, right? 5t1 divided by 2. Your value. 2. 290. Oh, sorry. 581 plus 1 divided by 2. Thank you, Pam. 291 exactly. Okay, if you get it in decimals also no issues, keep it in decimals. Okay, 291. Now I have to find where this 291 value lies. Okay. Actually, if I represent this data this way, kindly join. It may be look somewhat lengthier. Please kindly join, but What happens is 10. What's my first step? I have to arrange it ascending order, right? What happens to this 10? How many times it occurs? 8 times. So actually when I go for arranging, it looks like 10, 10, 10, 10, 10, 10. How many tens? Two more. 10. Then we'll go for 11. How many times it occurs? 15 times. 11, 11, 11. I have to go for 15 times. Okay. Then I'll go for finding 12. 12 occurs for 20 times. See, it's a lengthy process, right? It's a lengthy process. So instead what we do is, we go for a shortcut. Always max is beautiful. Not because of formulas we are not liking max. Max is beautiful because we take the help of cumulative frequency and find the cumulative frequency. Very easily you can find the value. What do you mean by cumulative frequency? We have discussed in the earlier topic. What is cumulative frequency? What do you mean by the term cumulative? Accumulative. Adding out the values. See, accumulation is you accumulate. Okay, I add a AC in the front. When you say accumulating, okay, please remember when you say accumulating, it's not directly adding everything. You go for step by step addition. How many students sitting in the first row of my class? 3 students. Then I go for second row in my class, 3 students. Then I go for third row in my class, 4 students, which means what? 3, then it happens 6, then it happens 10, and so on. This is what you call as accumulating. As you were saying, addition. Addition is different and accumulation is different. Addition is the operation. Accumulation is nothing but where we go in a single, like a step-by-step manner. Okay. So here I have, yes, please join. Here I have, how many times 10 occurs? 8 times. After that only 11 occurs, which means 11 occurs for 15 times, which I need to add this value, which means 8 plus 15 is 23. Then from which place 12 occurs? From 20, which I need to add, which is 43, which means it goes step-by-step process. So as I was writing over here, tell me, how many times 8 occurred? 10 times. First row over. Then I go for the second row. Second row, how many times 11 occurs? 15 times. Okay, totally 23 numbers now. What is the frequency, total frequency? 23 as of now. Then how many times 12 occurs? 20 times it occurs. Which means what? I need to add. I say, okay, now totally it's 43 numbers. Likewise, I go step by step by step. Till how much I'll get? Till how much I'll get? 580. That's it. Yes, tell me, join. So I'm over here for 13. 143. Yes. 98. 241. And 95. 336. 426. 501. 550. 51. 581. See, remember when you talk about cumulative frequency, this is actually less than cumulative frequency. We have two types, remember? Less than CF and greater than CF. This is less than CF. When we talk about less than CF, this final value should match with 581. Why I'm doing all these is, I found the n value. Okay, I found the n value. What is the n value? 291. Now, what's my formula for median? Size of this observation. I don't know where this 291 will lie. It's a lengthy process. If I go for taking all the values like this, row by row by row, it will go as a lengthy process. So what I'm doing, I'm taking the cumulative frequency, and this size of n plus 1 by 2th observation now will be taken as CF greater than this 291th observation. So I was telling, we'll make two changes. One changes, instead of small n, use capital N. Second changes, instead of size, you use cumulative frequency greater than this value. So where this one lies? 291. You have to check over here. Where this one lies? See, CF greater than 291. Where this one 291 lies? Somewhere over here. So I need to go for the next value and the corresponding mark, which is 15. So your answer is. You remember what was the arithmetic mean? I asked you to do in two decimals. 15.09. What is my median here? 15. So you're getting greater. So obviously my answer should look like arithmetic mean greater than median, greater than mode. This is not always true. For different distribution, we have different meanings. Okay. So if arithmetic mean greater than median and this value is obviously mode should be some value lesser than median. Let us check that later. So this is the concept. So what's the formula? Let me come again. Yes, what's the formula? Median First step, you need to arrange in ascending order. Please remember, for discrete and continuous, it's already arranged and given to you. So you need not to worry about arranging. What's the second step? What's the median formula directly? Size of n plus capital N plus 1 by 2th observation. Okay, yes, please join. Instead of size, I'll be taking as CF greater than n plus 1 by 2th observation. That's it. Can you guess for cumulative Q1? What will happen? Size of this one alone will be changing. Size of, yes, please join. N plus 1 by 4 into 1th observation, which means cumulative frequency greater than this observation. Q3, CF greater than 3 into N plus 1 by 4th observation. Right? Yes. What else? O6, you can guess. D7, you can guess. And P75, you can guess. Will you make it? Yes, please. More. Actually, there are so many methods to find the mode value. First method is by location. By location means seeing the value you can easily identify. For example, in our question, what's the modal value? Modal value from our question. See, directly seeing the answer you can identify, right? Seeing the table. How many times it occurs? The highest number of occurrence will give you the mode value. How many times it occurs this value? 100 times. So this is going to be the mode value. Okay, so this is one method. So this is by location we say has 100, the modal value. But what happens here is we have to see the regularity of the jumping of values. For example, here the F value is 8. Okay. What happens? 15 is a normal jump. See, what do you mean by 15 is we got first 8 values 10, 10, 10, 10. Then next value 11, 11 for how many times? 15 times. Then it's okay. What happened here? 12, 12, 12 for 20 times. Then it's okay. What happened here? See, there's a big jump. So we say here the values are irregular. If the values are irregular, location method will not give you the correct answer. Okay, if the values are irregular, location method will not give you the right answer. So that's another method, what you call as the grouping method. That's what we're going to do here. Okay. And already in the very first problem, we were discussing this one, right? For individual observation, the empirical relationship to find the modal value. What's the empirical relationship? Mean minus mode is equal to 3 times of mean minus median. Using this, you can find it. But when this one will be useful? Not in all the cases we use this formula. When this one will be useful? Only when? Yeah, please. Only when M naught is ill-defined. You remember? Usually we'll go by location method. If not by location method, if it happens to be irregular in nature, the frequency has a big jump, then we'll be using grouping method. And also by grouping method, if we find that the mode is ill-defined, then we'll go for empirical relationship. So this formula, empirical relationship, is a thumb rule. Okay, you know what do you mean by thumb rule? It's a thumb rule. So we use this method only when it is ill-defined. Only when the mode is ill-defined, we use this relationship to find the modal value. So what is this grouping method? Shall I take over? What is this grouping method? So let me go for the values. Yes, can you get me the values? Marks. Yes, starting from 10 now. 10, 11, 12, 13, 14, 15, 16, 17, 18 and 19. Frequency. Yeah. Frequency is original frequency, which is given in the table. Yes, can I get the value? 8, 15, 20, 100, 90, 8, 95, 90, 75, 50 and 30. Okay. The grouping method, by the name itself, we said we are going to group the values. So first I'm going to group in twos, which means I'll group this way. Okay. See, what I mean by mode is nothing but a measure of center tendency. What do you mean by center tendency? So many values are here and everybody will be, that is all values will be tending to one value. That value most probably it will be the center mission, center value. So that's why they use the name called as central tendency. Okay. So here, instead of taking single value as 10 and 11, what we are going to do here is we are going to group in twos. Twos means in pairs, which means 10 and 11 put together, how many times it appears? Please try to understand. 10 and 11 put together, how many times it occurs? 23 times. Am I right? 12 and 13 put together, how many times it occurs? 120 times. 98 and 95 put together, which means 14 and 15 put together, it appears for 1, 193 times. 16 and 17 put together occurs for 165 times. And 18 and 19 occurs for 80 times. If this was not the original frequency and this was the original frequency, which would be your modal value? This one, right? See, from the original frequency, we found this, that is 13 is taking the modal value. But because of some small grouping, see, intentionally I'm going to tend to the central value. Because of some small grouping, I'm getting 14 and 15 as modal value. See? Likewise, I can do it further. So when you say central tendency, the last values will not be given importance. Ultimately, only for mean we give importance. For median and mode, we will not give importance for last values, which means if we go for drawing this as a graph, I'll get it this way, where my mode and all will lie. Here only mode will lie, right? What do you mean by mode? The peak most values. So this is going to be mode value. This will be ultimately somewhat in the middle only because it's central tendency version. It's ultimately will be in the middle only. So I'm not going to worry about the smallest value. I'm not going to worry about the largest value. So instead of taking the first one, I can make the other two in groups. This is leave the first one and group the other in twos. Okay. Yes. Which means what? I'm not going to consider 10. Instead, 11 and 12 put in groups. Which means 15 and 20. See, 15 plus 20, 35. Okay. Next two in groups. That's for 13 and 14. 100 plus 98. 198. Okay. Next two in groups. Yes, 90. This is 95 and 90. Yeah, 185. Next two in groups. 75 and 70. 125. And the last one does not have a pair. Just leave it. Again, if you check here, which one would be the modal value? 98. This is referring for 13 and 14. See, now there is a confusion. Either you are going to take 100 as the modal value, that is 13 as the modal value. Here, 14 and 15 can be taken as a modal value. Here, what happened? 14 and 15 can be taken, 14 and 13. No? 13 and 14 can be taken as a modal value. There is a lot of confusion. So, I'm just going to form another one table. Okay. I name this is column number 1. Okay, I name this is column number 1. Yes, what is column number 1? The original frequency. Which one is the modal value? 13. I list it out 30. Okay. Now I go for this is column number 2. Which one is my modal value? I got 14 and 15. I'm getting 14. I'm getting 15. Third column. Which one is the modal value? I'm getting 13 and 14. Likewise, I do it further. This is third column. I add one more column, fourth column. Fourth column will be grouping in threes. Okay. Yes, tell me what's the value if I group in threes. So if I group in threes, this is going to be for 10, 11 and 12. Yeah, 8, 15 and 40. 43. Yeah. Then again in threes. 100, 98 and 95. 298. Then 298. Then again in threes. What's the value? 215. So if I do this way, what would be my modal value? Highest is 298 and this 298 is corresponding for 13, 14 and 15. This would be my modal value. So this is from column 4 where I am getting 13, 14 and 15. Okay. Just check whether I have all my values scattered. Okay. How it is scattered? Probably 10, 11, 12, 13, 14, 15. See, you know this, you play this game in the hotel restaurants and all, they have the paper, table paper. You link all the dots. You connect one, two, and you'll get a shape of a dog or some toy or something like that. It's such type of a game only here. But what we do is we group 10 and 11 together. We'll get it like a small patch. Okay. 12 and 13 together. We'll get a small patch. After grouping all these, now your data will not be very scattered. Instead, 10 and 11 here, 12 and 13 here, 14 and 15 here. Okay. Still more you group it. Then you group it as, leave of 10. 11 and 12 here. Okay. 13 and 14 here. We'll get a small patches. Ultimately, instead of having the values so scattered, it happens like it is all going to be very closest in value. Okay, that closest value only I'm trying to find here. Okay, so this is fourth column. Now come for the fifth column. Which means leave the first one and group the other in threes. So leave the first one. Okay, 10, 11 and 11, 12 and 13. Yeah, value 15, 20 and 120. 135. Am I right? Then other threes. 98, 95, 90. 2, 283. And I have another three pairs. 17, 18 and 19. Yeah. 150, 155. So if I do this way, what would be the modal value? 283. This is with respect to 14, 15 and 16. So this is for fifth group referring to 14, 15 and 16. Now I can still furthermore drag till the next column, which is column number 6. Okay. Leave off the first one, leave off the second one, and group the other in threes. Which means leave off the value number 10, leave off the value number 11, and group the other in threes. Yes, please. For 12, 13, and 14. To 18. For other threes. 15, 16, and 17. 95, 90, and 75. Yeah. 260 exactly. Yeah. Okay. And for 18 and 19, there is no pair because I need to group in threes. So leave off the last three. So if I do in this way, what would be my modal value? 260. This is referring for which values? 15, 16 and 17. Okay. So now let me add over here. This is for 15, 16 and 17. Okay. So I tried grouping in this way. Now I find that many values are repeated. How many times is this repeated? 13. 1, 2 and 3. 3 times repeated. How many times 14 is repeated? 1, 2, 3, 4 times is repeated. How many times 15 is repeated? 1, 2, 3, 4. 4 times is repeated. 16 for 2 times. 17 for once. If I have a key look on this table, I find that 14 and 15 is repeated 2 number of times, which means what? Equal number of times. So my mode value is actually what? Ill-defined. How you do the modal value? The highest value, right? If there is repetition of value, 3, 6, 48, 24. What's the modal value? Why you say it's ill-defined? Because 3 it's only once, 6 once, 48 once, 24, which means equal number of repetitions. If there are equal number of repetitions, you cannot talk about mode. So here, what's the mode here? 14 is repeated 4 number of times. 15 is also repeated 4 number of times. Which means what? We have equal number of repetitions. Mode is ill-defined. By location method, it was 100. Okay. By this method, it's ill-defined. So ultimately, we go for empirical relationship. If empirical relationship method, get me the value. Mean minus mode is equal to 3 times of mean minus median. Mean, I remember 15. I don't know what's the value. Mean is arithmetic mean only. Make it for 2 decimals. Okay. Minus 3 times of 15.09 minus median. Median is 15, right? Yeah. Get me the value, Bob. 3 into 0.09 and this side is, I can get the direct value please. 15.09 minus 3 times of 0.09. Direct value please. 8. So we check that arithmetic mean is greater than geometric mean. So not geometric mean. Median greater than mode. Okay. So actually, till now we have three methods. One is location method. Second is grouping method. Not always grouping method. When we use the grouping method, when there is a jump, high jumps, then even though using grouping method, if I do not get the mode value, then I go for using empirical relationship. Okay. So ultimately, this is in some cases we get this relationship between the three averages, but not always. Yes, please make a note of it. Okay. Actually, I just wanted to discuss this one. So under location method, under grouping method, but under empirical relationship, mode is 14.82. Actually, this will bring the issue on accuracy. What's the issue on accuracy means? When you say mode, highest number of repetition will be one value, right? If you're getting the value as 14 or 15 means is right. But you're getting the value as what? 14.82. Where is 14.82 here? You get my point? Actually, from this table, can you tell me where is 14.82 from this table? Where is 14.82? 14 is there, 15 is there, 14.8 is not there. So it's bringing an accuracy issue. See, each and every method will have a drawback. Okay. So that's about mode. Yes, you can do measures of dispersion. That's all for today, I think. You complete this, today's session is over. Measures of dispersion, you know, right? What you have to do. The same application. Range, you will find largest minus smallest. Coefficient of range, L minus is divided by L. Actually, you can multiply by 100. If you multiply by 100, you'll get the answer as 31%. You can do it. Quartile deviation, we have already found Q3 minus Q1 and Q3. So just substitute over here coefficient of quartile. Only thing you have to work out mean deviation and standard deviation. Mean deviation formula usually will go for, if nothing is better, mean deviation about mean only. So we work out only for mean. We need not work out for median or mode. Okay. Most of the time the question will be given directly. And standard deviation, the same formula. Variance, S square, coefficient of variance, S minus X bar into 100. Yes, I can do it, please. I'm not going to work out. If any doubts, we'll discuss. Yes, we can start.